Bathymetry is the study of underwater depth of lake or ocean floors. In other words, bathymetry is the underwater equivalent to hypsometry or topography. The name comes from Greek beta alpha theta upsilon sigma deep and mu epsilon tau rho omicron nu measure. Bathymetric charts are typically produced to support safety of surface or subsurface navigation, and usually show seafloor relief terrain as contour lines and selected depths, and typically also provide surface navigational information. Bathymetric maps may also use a digital terrain model and artificial illumination techniques to illustrate the depths being portrayed. The global bathymetry is sometimes combined with topography data to yield a global relief model. Paleobathymetry is the study of past underwater depths measurement. Originally, bathymetry involved the measurement of ocean depth through depth sounding. Early techniques used pre-measured heavy rope or cable lowered over a ship's side. This technique measures the depth only a singular point at a time, and is therefore inefficient. It is also subject to movements of the ship and currents moving the line out of true and therefore is inaccurate. The data used to make bathymetric maps today typically comes from an echo sounder mounted beneath or over the side of a boat, pinging a beam of sound downward at the sea floor from remote sensing LiDAR or LiDAR systems. The amount of time it takes for the sounder light to travel through the water, bounce off the seafloor, and return to the sounder informs the equipment of the distance to the seafloor. LiDAR LiDAR surveys are usually conducted by airborne systems. Starting in the early 1930s, single-beam sounders were used to make bathymetry maps. Today, multi-beam echo sounders are typically used, which use hundreds of very narrow adjacent beams arranged in a fan-like swath of typically 90 to 170 degrees across. The tightly packed array of narrow individual beams provides very high angular resolution and accuracy. In general, a wide swath, which is depth-dependent, allows a boat to map more seafloor in less time than a single beam echo sounder by making fewer passes. The beams update many times per second, allowing faster boat speed while maintaining 100% coverage of the seafloor. Attitude sensors allow for the correction of the boat's roll and pitch on the ocean surface, and a gyro compass provides accurate heading information to correct for vessel yaw. A boat-mounted global positioning system positions the soundings with respect to the surface of the Earth. Sound speed profiles of the water column correct for refraction or ray bending of the sound waves owing to non-uniform water column characteristics such as temperature, conductivity, and pressure. A computer system processes all the data, correcting for all of the above factors as well as for the angle of each individual beam. The resulting sounding measurements are then processed either manually, semi-automatically or automatically to produce a map of the area. As of 2010, a number of different outputs are generated, including a subset of the original measurements that satisfy some conditions or integrated digital terrain models. Historically, selection of measurements was more common in hydrographic applications, while DTM construction was used for engineering surveys, geology, flow modeling, etc. Since California, 2003 to 2005, DTMs have become more accepted in hydrographic practice. Satellites are also used to measure bathymetry. Satellite radar maps deep-sea topography by detecting the subtle variations in sea level caused by the gravitational pull of undersea mountains, ridges, and other masses. On average, sea level is higher over mountains and ridges than over abyssal plains and trenches. In the United States, the United States Army Corps of Engineers performs or commissions most surveys of navigable inland waterways, while the National Oceanic and Atmospheric Administration performs the same role for ocean waterways. Coastal bathymetry data is available from NOAA's National Geophysical Geological Data Center, which is now merged into National Centers for Environmental Information. Bathymetric data is usually referenced to tidal vertical datums. For deep water bathymetry, this is typically mean sea level, but most data used for nautical charting is referenced to mean low water in American surveys, and lowest astronomical tide in other countries. Many other datums are used in practice, depending on the locality and tidal regime. Occupations or careers related to bathymetry include the study of oceans and rocks and minerals on the ocean floor, and the study of underwater earthquakes or volcanoes. The taking and analysis of bathymetric measurements is one of the core areas of modern hydrography, and a fundamental component in ensuring the safe transport of goods worldwide.